department has to be maintained, to be brought in at an early stage of any planning using bunkering medium, and because the management people might need additional training when LNG is added into the equation. They might not have the expertise. They might not have the experience in training in LNG fire, a fire like that. So they make additional training and prepare for the advent of LNG as a bunkering medium. Water deluge systems, we've looked at those relatively closely. They're commonly found in our terminal operations. When you start looking at the LNG, more efficient, better water deluge systems, particularly control of vapor sugars, once into this vapor, as indicated earlier. We can control the first times by using water deluge or spray system, whatnot. So these become an integral part of the emergency procedures program. Flaring cargo. Flaring cargo is a huge issue in our society today, and what has been seen in the past is effluent or waste from the refining process, or from basically the refining process, where this effluent is flared off because in the eyes of the refinery, perhaps these products have no economic value, or the recovery of these products to make them into some type of economic feasible product, expensive, whatever the case may be in the past. This is changing in our more environmentally aware society as regulations become more stringent regarding emissions. Refineries now forced to find ways to deal with effluent and dispose of it in an environmentally friendly way. The mast riser, vent riser issue, again, is more of a review section. The main idea is here is the terminal or the vessel or whatever the case may be, wherever the LNG is going to be transferred and stored. If operators are maintaining a proper or close eye on pressures, vent risers are not going to be an issue. Usually the only time a vent riser comes into play be under some type of an emergency situation where pressure's gotten out of control. Again, the operators are responsible for keeping tank pressures under control so they don't wind up into a position where they have to leave tank pressures through a vent. The fire control aspect of it we have seen already. That will not have changed when we get to that particular section present. A review of the flammability characteristics of gaseous natural gas. Once again, LNG natural gas is odorless, colorless, non-toxic, and very, very important to bear in mind is asphyxia. The flammable limits for things remain in that lower flammable limit of 5%, flammable limit of 15% range. This is the concentration of methane in air that is flammable. Anything outside of these limits will not burn, will not ignite, because it is either too lean if it's less than 5%, or it is too rich if it's above 15%. So it's this narrow range that we have to be aware of. And this is why we have our gas detection system strategically located throughout the ship, located in strategic locations throughout the ship, so that if we do get the slightest hint of gas in the air by any volume, we will be alerted to us. The number that you want to remember is 30% of LEL, 30% of 5%, 1.5% by volume. 30% of L is where the gas detection systems are set to arm, which gives advance notice, plenty of advance notice that there is a problem. Any type of leak you're going to get, unless accepting a major catastrophic failure, you will have an indication that there's a problem long before the problem becomes major. And this is why we have our gas detection systems on board ship and within terminal. So if we get to that 30% of LEL, there's a warning. Okay, we're not anything here. Three things are necessary to have fire: air. We need some fuel and the ignition. That ignition source can be any small source, any major sequence. Electricity can an ignition source. This is always of ignition. Anytime we're flammable, anytime we're dealing with a flammable gas. So without without one of three, you can't have fire. If we have no oxygen, in other words, if we put background, a nitrogen background, something like that, watching the video that was by the BBC, they had that containment and they filled it with night inside that environment wouldn't burn. Fuel don't have these things. LNG storage can transport organic spirit for several reasons. Release of liquid bread on the ground and potential gas evaporates. Your LNG storage tanks are constructed out of cryogenic materials. I know very, very few instances that major, I don't know of any, I think it is major catastrophe in Cleveland, Ohio, 1994, it's been structural materials. You have that possibility of a tank that may be in a seismic, is one of the things that is studied extensively when a facility is sited or when a storage is going to be sited. If the studies have and have to be taken. I was in Japan, and of course, Japan is a very active seismic area. So in Japan, the standards regarding to society are very, very stringent, and there are construction measures taken in Japan, which are not necessarily taken in other areas where you're not the possibility. This is one of the possible reasons you can attack is if there was some type of seismic activity and the tank construction wasn't such it would withstand it. Terrorism, obviously, is another issue. Is taken in. That's why we had security precautions taken anywhere where we're going to site an tank. But the idea is that if a tank does have a leak, you are going to have a pooling of energy in the air around that. And when have that pooling, you are going to generate a hazardous vapor cloud. Six of vapor cloud are determined the volume of the larger the vapor clouds. The shape of the pool will also have an impact on the way that vapor bursts, and the larger the pool, the larger the surface area, the larger the surface area, more exposure to the ambient temperature. So the evaporation rate of the pool is going to depend upon its size, upon its shape.
Hi, John. Can you hear me? This is Jared. Can you hear me?
No.
No?
I can't, Joe.
Oh, good. Well, the issue has not resolved itself. So what I propose
Can
is
you
that,
hear me?
yes, I can hear you, but you're very intermittent. So if you can hear me, I would like, maybe I'll call you on your phone, but let's restart your whole desktop and reboot the system. And then hopefully that will correct itself. Okay, so I'm going to end the session.
Okay.
And then we'll restart
Okay.
the computers and start over. Not start over, we'll go back to slide 9, but try this again. I will call you on your phone. I'm going to end the session.
So we will start the computer.
Going to do it.
Yeah.